Okay, so today's video is on function operations. It's the second part of lesson 4.5, and we are covering division and modeling real world formulas. Okay, so the good news is a lot of this is exactly the same thing that we did yesterday. Basically, you got the same type of notation. So if you see f divided by g of x, that just means take that first function and divide the second function. Now, I'm going to remind you that this second one is what Desmos understands. It just makes more sense, but you're probably going to see the left side written in your benchmark or the EOC or your quizzes and your assessments. The domain is the same. You do look at the domain where they are shared, and I'm actually going to show you a really good one on Desmos in a minute, where you can definitely see the difference in the two domains. But you're not allowed to divide by 0. And we didn't talk about it yesterday because we weren't dividing. So the quotient does not include any values for when the denominator equals 0. That is what that says. So if you're dividing by g of x, that means g of x can't be 0. So if there is an x value that exists in the second function that you're dividing by, and it makes a 0, you can't use it in the domain. All right, we're going to go ahead and do this one. This is a division problem, and it says we're going to take the little f and we're going to divide it by g. So I'm going to immediately rewrite that into something that makes a little bit more sense. So that means f divided by the g function. Just make sure that you're paying attention to the order, because sometimes they might swap it on you. So if they say like g divided by f, make sure you go in that order. So the f of x function is 6x, and the g of x function is x to the power of 3 over 4. Now, to do these function operations, you really need to be kind of like a pro at all of your exponential rules. So let me remind you of those very quickly. You don't have to write any of this down, okay? So if you've got x to the power of 3 times x to the power of 4, what is the rule for the 3 and the 4? We add them together. Good, okay? If you have x to the power of 3 divided by x to the power of 4, what is this rule? We subtract them. So it'd be x to the power of negative 1. Make sure that you go in order. So 3 minus 4, that's your result. Okay, and then if you have a power to a power, so let's say you have x to the power of 3 to the power of 4, so you only have one base, that's called power to a power. You're going to multiply them together. Another skill that you need to know to be successful is if you see something written to the power of 1/2, you may or may not need to rewrite that as the square root of x. So remember, anything that has a fraction exponent, the denominator is the root. So if I change that to 1/3, that would become a cube root. And if this 1 is anything other than a 1, you're going to have to put a square here, or you'll need parentheses and put square. Okay? So those are all things that you need to know to be successful in this lesson. So let's go back to the question at hand. This has an exponent. It's 1. Okay, when you're doing exponential rules, please write the invisible 1. That way you can see it. Now the 6 doesn't have any other whole numbers to deal with, so I'm just going to leave that 6. A little known fact, when you are using this exponential rule, so if you're dividing your powers, no, I said it wrong. If you're dividing the x's, the same base, you subtract the exponents, but the result is always in the numerator, always. So if you subtract 1 and 3 over 4, you get positive 1 over 4. And you write it in the numerator, okay? Okay, so underneath this, it says that we are going to evaluate f divided by g of 16. This does not mean multiply by 16. It means to substitute 16 for x. So I'm going to take my result, which was 6x to the power of 1 over 4, and I'm going to substitute 16. So now remember, on your benchmark, your EOC, you've got this big section at the very beginning where you're not allowed to have any calculator of any type. So we're going to just do this part by hand. Remember I told you that 1 over 4, you can rewrite that as a radical. So I'm going to just leave the 6 kind of by itself because it doesn't have a power of 1 over 4, but the 16 does. So that's going to be the 4th root of 16. So that's a pretty common 4th root. So what's the 4th root of 16? So 2 to the 4th power is 16. So that means that that's going to be 2. And then just 6 times 2 would be 12. Now, if you have your calculator, you can absolutely type that in. No big deal. Okay, so to do the domain, what you have to do is you have to consider each function. So the first function is 6x. 6x. Now, I keep having kids ask me, like, how do I know this is linear? It's because it's got x to the power of 1. That's the highest power. So it's linear, and linear looks like a straight line, okay? You need to know that it's basic. The parent function is a straight line, and you need to know that it is all real numbers. There is no limitations. There's no start, no stop for the domain, for any of the x values. So you can plug in any x value into 6x, and you'll get a response. Like it'll work, okay? Now, the second one, this one's brand new to you guys. We have not talked about the domain of that one. So remember I told you that the denominator is the root. So that's actually a 4th root. So you guys know that the square root of x looks like this, right? Well, guess what? Anything that has an even root will also look like that. So a square root looks like that, a 4th root, a 6th root, an 8th root, a 12th. It's even. So if you're taking an even root, what that means is that you're not allowed to take or plug in a negative number. So that's why it's limited. Now, if that's an odd number, so if that was a cube root, it'd be different. It would have no limitations, but it's an even root. So if you take something that has all reals, and then you take something that only has positive values, where is it shared? Only the part that has positive values. So I'm going to start by writing my domain that looks like this. So all of the positive values, including 0. So instead of me just talking at you, I want you to see it. So this is, this wasn't f of x, it was g of x, right? Okay, so we're dividing by g of x. This is what it looks like. Now, do you guys see any value that would be 0? It's this first one right here. You see it? Okay. So the value of x that makes the function 0 cannot be included in the domain. I'm going to say that again. Okay. So if x equals 0, if you plug in x equals 0, your y is 0. So what that means is that you cannot use x is 0. It's not going to work. So what you're going to have to do is you're going to have to come back over here, and you're going to have to remove that part from your domain. So that's actually pretty easy. All you got to do is just take that out and just put greater than. So if you're dividing, okay, chances are you're probably going to remove the 0 from your final domain. Okay, so the next part is using technology, and you already have your computers open. So I need you to type in f of x and type in g of x. What you're doing is you are coding your computer. If you don't type in the function, it's not going to know what to do. So I'm going to pause it. I want to give you a chance to do that. So Desmos is really awesome. So it just graphed it for us. And there's no way you're supposed to know what g of x looks like. That's perfectly normal, okay? So what we're going to do is we're going to look at the domains for a second. So if you click after your f of x, go ahead and just hit enter. And I want you to hide the second one for a second. So I don't want to look at the half circle. What is the domain of the square root of x? We should know that. The domain is x greater than or equal to, and you're going to have to click on your little keyboard down here to get that 0. So if you graph x is greater than or equal to 0, it shades all of the x values where that graph exists. Okay, so it should start at 0, and then it's all those positive numbers past that. Okay, now go ahead and hide that. Now the second one, though, let's look at the second one. So hide everything but the half circle. And then we're going to hit enter, and we're going to type in this domain. Now this domain is limited. There is a minimum and there is a maximum. What is the minimum number on this x? The minimum x value on this graph should be -3. So I'm going to type in -3. Now nothing happens, okay? That's the minimum. Then we're going to do less than or equal to. So this is how you type in a compound inequality. X. Now you see what happened? It kind of started at -3 and shaded everything to the right, but it's not everything to the right, is it? It's got a max. So we're going to hit another less than or equal to. And then now what's the maximum number? It stops at 3. So do you see how that's how we type that in? So the minimum is -3, the maximum is +3, and we're including all the values between that. And that's how you do a minimum and a maximum using a compound inequality, okay? Now hide that. Okay, now look back right here. So I've got my two functions. Can you see where they overlap? They have some shared space and they have some that's not shared. So let's see if we can make Desmos show us. So click on both domains. Okay, you see that middle section where they kind of both run into each other? That's going to be the domain of the combination of the functions. So if I wanted to add the functions, my domain would go from 0 to 3. If I wanted to subtract them, it would go from 0 to 3. If I wanted to multiply, it would go from 0 to 3. But if I divided, you can't include 0. So it would be everything greater than but not equal to 0. So it'd just be greater than, but it'd still be up to 3. So I hope that makes sense. So now I want you to go ahead and get rid of the domains. So get rid of them completely. Now look at your notes again. So your notes say, find f plus g of x. Now y'all know how to do that, but your notes is asking you to do like all of these things, but they say when x equals 2. When x equals 2. So go back to Desmos again. And you're going to have to tell Desmos to plug in a 2. How do you do that? So we're going to type in f of, now if you type in f of x, it just brings up the generic function. But we are trying to substitute a 2. So you have to put a 2 in here. Now look what it does. It automatically plugs a 2 into that f function. Okay, but your notes, what they're wanting you to do is add them together, right? So we're going to do plus g of 2, and it automatically does it for you. So Desmos is taking this 2 and plugging it into the red function. It's taking this 2 and plugging it into the blue function, and it's adding them together for you. If you type in g of x plus f of x, it will not add them for you. It will just show you the result. So let me make it clear to you. Desmos will not do the algebra stuff for you. It will do the evaluation for you, though. And it will graph it for you. But it will not add integers for you. It never has and it never will. Okay? So let's go back. Let's put our 2's in here. So I got 2's. Okay? We can copy that. Do you know how to copy and paste? So we're going to copy it, and then I'm going to paste it here, and I'm going to do minus. And then I'm going to paste, and I'm just going to take out the plus sign because that means to multiply them, right? So you see how fast Desmos can do these operations for you? Okay, now the last one, though, I'm going to have to type that one in because it's division. So divided by g of 2. And you've got all 4 of your answers right there. Desmos will do that if it asks you to evaluate, but it will not add functions or take away functions if it's just the algebra part. Okay, I'm going to pause it. We're going to write down the answers on our notes. Okay, so here's the answers that you get after you type it into Desmos. Make sure that you're rounding to 2 places. And make sure that you're substituting 2 instead of putting f of x and g of x, because it'll only just show you the graph. All right, so this is a modeling problem. We actually have a couple of real world functions that measures the heart rate of a white rhino according to their body mass in kilograms, which is M. And then you have one about a typical lifespan according to the body mass in kilograms. So what they're wanting you to do is they're wanting you to do that. What does that mean? What does RS of M mean? Okay, so that means to multiply R of M and S of M. So I'm going to do R of M times S of M. So we're going to multiply them together. Now, after we multiply them, we're going to talk about like why we did that. So R is 241 M to the power of negative 0.25. And S, that is in scientific notation. And the commutative property allows me to rearrange things that are being multiplied. And everything in this is being multiplied. It looks kind of crazy, but all of it's being multiplied. So those are my like whole numbers, and these are my variables. And notice your variables are the same. So I can combine the variables to be one variable. I'm going to write 241 times 6 times 10 to the power 6. And then I'm going to put m to the power negative 0.25. And then m to the power 0.2. So I'm going to go ahead and multiply, but when you're multiplying your scientific notation, you're going to multiply 241 times 6, and you get 1,040. You get 1,446 times 10 to the 6th power. What am I going to do over here? How do I combine them? What's the rule for that? I think we have to add them together, right? So if you have the same base, you add your exponents. So you get negative 0.05. But if you have something that starts out in scientific notation, you have to write it in scientific notation. While that looks like it's in scientific notation, this is not scientific notation. Okay, so this number, for it to be in scientific notation, it needs to be between 1 and 10. So I'm going to take the decimal, which is like right here after the 6, and I'm going to move it to be here. So I'm now going to write 1.446. Now you can't just rewrite the decimal without having some kind of a balance to it. So if I move my decimal to the left 3 places, I'm going to add 3 to the 6. So that's going to be 10 to the power of 9. Now, the reason why I did that is because 1,446 is 1.446 times 10 to the power of 3. Because it's times 1,000, because I moved the decimal 3 places, and that's 1,000. So 10 to the 3rd power times 10 to the 6th power is 10 to the power of 9. So that's why you do it, but that's going to be your final answer. And let's talk about why we multiplied it. So I want you to go back up here. I want you to consider you've got heart rate and you've got lifespan. So what happens when you multiply the heart rate times the lifespan? So what it does is it tells you how many beats or heartbeats, how many heartbeats the rhino had over the entire lifespan. And you can do that if you inputted like the mass of that, and you can just kind of predict how many beats it's going to beat over the entire life. All right, so here's the results of multiplying the 2 and dividing the 2. So when you multiply them and you combine your x, you have to add the 1 and the 1/5. That's where the 6 over 5 comes from. And then on this one, you have to subtract your exponents because you're dividing the x's. So what we want to do here is we want to plug in 32. And you can use Desmos to do that, but it's actually really easy. So let's just plug in 32 by hand. So I'm going to put 32 here, 6 over 5. Now, if you're doing it by hand, that's going to be a 5th root. And the most common 5th root is 32. So the 5th root of 32 is 2. Oh, that's a big number. I don't think I could do this by hand. Let's pop that in our calculator. So I just typed in my calculator and got 192. They're not going to ask you to do anything like that difficult without a calculator. Same thing over here. I'm going to do 3 times 32 to the power of 4/5. And I got 48. Awesome. Okay, so let's talk about domain. Where are they going to have anything in common? So the 3x is linear, so that all real numbers, so there's no limitations. It's like literally the whole entire graph is shaded. But this one has an odd root. So an odd root does not have any limitations, so it's all real. So guess what? They're both all real. That means the domain is also going to be all real numbers. And that's when you multiply. But when you divide, you're going to have to like subtract that 0 value. So it's basically going to be everything but 0. So all real numbers but 0. All real numbers but 0. Okay, so on this one right here, it's asking you to evaluate when x equals 5. So I need you to type the f of x in. So you're going to type all of that into Desmos, and you're going to type all of this into Desmos, and then you're going to use Desmos to evaluate for you. So Desmos is very handy when you're evaluating. So you got to type in the blue one, type in the green one, and then you got to plug in 5. So when you add, it's going to look like that. And when you subtract, it's going to look like this. Okay, and you got to do all 4. So you're going to multiply, and then you're going to divide. So this is the result that you get when you type them into Desmos. Okay, so take a second and look at this last one. It is a modeling problem, and they're going to want you to kind of like apply this to real life. Take a second and work it out. Pause the video and unpause it and see if you get the answer correct. Okay, so I've got the problem set up here. I just want to make sure that you understand that if it says b minus a, you have to write the f of b equation first, then we subtract the a equation. If you simplify the like terms, you're going to wind up with 0.15x, and then the ones cancel out. So that's what happens when you subtract city B and city A. So what does this actually mean? So this is actually the cost of renting a scooter for X minutes. So if you look at this right here, you have so many minutes, and the difference between the two cities is 0.15. So what I would think it means is that it seems like city B, because that one was first, city B is going to be 15 cents more expensive to rent the scooter per minute than city A.